Buckle up, space enthusiasts. Get ready to uncover the secrets hidden within the enigmatic depths of our solar system's most mysterious ice giant. Because NASA's groundbreaking discovery on Uranus is about to leave you breathless. For the first time, NASA scientists have strong evidence of a polar cyclone on Uranus. By examining radio waves emitted from the ice giant, they detected the phenomenon at the planet's north pole. The findings confirm a broad truth about all planets with substantial atmospheres in our solar system. Whether the planets are composed mainly of rock or gas, their atmospheres show signs of a swirling vortex at the poles. Voyager 2's imaging. Scientists have long known that Uranus' south pole has a swirling feature. NASA's Voyager 2 imaging of methane cloud tops there showed winds at the polar center spinning faster than over the rest of the pole. Voyager's infrared measurements observed no temperature changes, but the new findings, published in geophysical research letters, do. Using huge radio antenna dishes of the Very Large Array in New Mexico, they peered below the ice giant's clouds, determining that the circulating air at the North Pole seems to be warmer and drier, the hallmarks of a strong cyclone. Collected in 2015, 2021, and 2022, the observations went deeper into Uranus' atmosphere than any before. What do these observations tell us? These observations tell us a lot more about the story of Uranus. It's a much more dynamic world than you might think, said lead author Alex Akins of NASA's Jet Propulsion Laboratory in Southern California. It isn't just a plain blue ball of gas. A lot is happening under the hood. Uranus is showing off more these days, thanks to the planet's position in orbit. It's a long haul around the solar system for this outer planet, taking 84 years to complete a full lap. And for the last few decades, the poles weren't pointed toward Earth. Since about 2015, scientists have had a better view and have been able to look deeper into the polar atmosphere. Ingredients for a cyclone. The cyclone on Uranus, compactly shaped with warm and dry air at its core, is much like those spotted by NASA's Cassini at Saturn. With the new findings, cyclones, which rotate in the same direction their planet rotates, or anticyclones, which rotate in the opposite direction, have now been identified at the poles on every planet in our solar system except for Mercury, which has no substantial atmosphere. But unlike hurricanes on Earth, cyclones on Uranus and Saturn aren't formed over water. Neither planet is known to have liquid water, and they don't drift. They're locked at the poles. Researchers will be watching closely to see how this newly discovered Uranus cyclone evolves in the coming years. Does the warm core we observed represent the same high-speed circulation seen by Voyager? Akins asked. Or are there stacked cyclones in Uranus' atmosphere? The fact that we're still finding out such simple things about how Uranus' atmosphere works gets me excited to find out more about this mysterious planet. The National Academy's 2023 Planetary Science and Astrobiology Decadal Survey prioritized exploring Uranus. In preparation for such a mission, planetary scientists are focused on bolstering their knowledge about the mysterious ice giant system. Uranus is an odd world. Studies have since shown Uranus to be a very odd world. While the rest of the planets in our solar system spin like tops, Uranus lies on its side. And although it is not the farthest planet from the Sun, it is the solar system's coldest. Uranus also endures seasons of extraordinary magnitude. Each pole spends decades bathed in nonstop sunlight before experiencing decades of total darkness. A human being who was born at sunset near the pole disappearing into autumn darkness would have to wait 42 years to see their first spring sunrise. For good measure, Uranus is the only planet to be named after a Greek rather than a Roman god. Uranus was the grandfather of Zeus. Despite these astronomical oddities and extremes, surprisingly little effort has been made to get up close to Uranus. Only one robot probe has ever visited it, in 1986, when the U.S. Voyager 2 craft swept past on its grand tour of the solar system. It revealed a massive, featureless, pale blue world with an atmosphere of hydrogen, helium, and methane, a rich family of moons, and a powerful magnetic field. And that has been that. Such slight regard is about to change, however. Earlier this year, the U.S. National Academy of Sciences published a report that urged NASA to launch a Uranus probe as its highest priority flagship mission for the next decade. The Academy publishes a report on U.S. priorities in planetary exploration every 10 years, and each decadal survey carries enormous clout, which means NASA is now under enormous pressure to design and fund such a mission. Interplanetary spacecraft of the future. Every decade, the planetary science community lays out a set of recommendations for what to prioritize during the next 10 years of exploration and research. The resulting document, known as the Planetary Decadal Survey, is used as a guide by NASA and the National Science Foundation as they decide which projects to invest in. The last decadal survey, published in 2011, recommended that the community prioritize a multi-pronged Mars sample return mission. NASA's Perseverance rover is currently completing the first phase of this assignment as it traverses the red planet's surface, collecting and storing Martian rock and dirt for eventual return to Earth. The 2011 survey also recommended a mission to Jupiter's icy moon Europa, which is one of the most promising places in the solar system to search for life. That led to the Europa Clipper spacecraft, which is scheduled to launch in 2024. The frigid realms of Uranus. Named for the Greek god of the night sky, Uranus may be key to understanding the thousands of planets orbiting faraway stars that scientists have spotted so far, many of which are roughly the same size as the ice giant. Uranus might be representative of the most common type of exoplanet out there, and we know so little about it that any science we get from the Uranus system would be invaluable. Planetary scientist Paul Byrne of Washington University in St. Louis writes in an email, "I can't wait to see this mission fly. We don't know how or when Uranus tipped over, or how such an off-kilter planet held on to such an orderly system of moons. Scientists don't know much about the planet's interior structure or why it's so much colder than Neptune. And Voyager observations of the planet's magnetic field show that it's really screwy, really offset and tilted," Hamill says. As we peer into the distant reaches of our solar system, NASA's discovery on Uranus unveils a captivating glimpse into the mysteries of this enigmatic planet. This groundbreaking revelation serves as a testament to human ingenuity and the insatiable thirst for knowledge that drives our exploration of the cosmos. With each discovery, we inch closer to unraveling the secrets of our celestial neighbors and gaining a deeper understanding of the vast universe that surrounds us. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.